Thank you for attending this presentation about my MEOPAR Early Career Researcher project, URIAS, Understanding and Predicting the Effects of Increased Shipping on Arctic Seabirds. The project gets its name from the thick-billed murre, whose Latin name is Uria lombia. They are the most abundant seabird in the Canadian Arctic. They have a circumpolar distribution, and they are very susceptible to oil spills, meaning that they are a good study species to understand the impacts of shipping and other stressors on marine animals. I would first like to acknowledge my co-authors, Allison, Emily, and Jenna, who are graduate students or postdoctoral fellows and who did most of the work I'm going to present today. Here we have 6 seabirds, murres, flying back from the ice edge, some of which were successful with fish in their bills and some of which were not. Whereas our knowledge of seabirds was once limited to what we could observe at the colony, we can now put electronic trackers on the birds to find out where they go at sea and what they're doing under the sea even. This is critically important in a changing Arctic where industrial development, including shipping, such as this large tourist vessel, the Crystal Serenity, is occurring at an ever more rapid pace. To find out what's happening at sea and where wildlife congregate, one option is to use an icebreaker, such as this one, which costs IPY about $150,000 a day. The other option is to use my volunteers, which work for free, or at least for fish. Rather than sensing a single track like an icebreaker, they spread out over a 300-kilometer foraging radius and report back what's happening on a daily basis. They tell us not only about hotspots for seabirds, but also for the fish or prey that they consume, and potentially where other marine predators might congregate. To track seabirds at sea, we must capture them, attach GPS loggers, such as the one you can see in this video, which has been sped up 8 times. After attaching the GPS accelerometer, we then release the bird and hope that it will return with what is essentially a $1,000 smartphone, miniaturized, and that it'll return back to give us back our data. Because it has a chick or egg at the colony, they're quite reliable and we get most of our little devices back. There it goes. Hopefully it comes back. This is the main study organism in the project, the murre. It has the highest wing loading of any bird, which basically means that it has small wings and a big body. This also means it has an exceptionally high locomotor cost. It has the highest locomotor cost of any animal. It basically has a metabolism of Usain Bolt, but rather than having to sustain this for 100 meters, it has to do this for hours and hundreds of kilometers at a time. It also means that they're really good indicators of what's happening at sea. If I were to ask you at a in-person conference to go get me a Danish, you might stop at the coffee machine or talk to a friend. These guys won't do that. They have to work as optimally as possible and as efficiently as possible to go out and get food and come back. We can use the fact that they're working very kind of optimally, if you like, to understand the constraints in their foraging range. In other words, it means that their movement is quite predictable. Here we have data from 30 colonies across the Arctic, and you can see that colony size alone predicts foraging range quite accurately, except at very small colony sizes. The white dot at the bottom shows where the breakpoint likely happens. On the right, we can see those data to model likely foraging ranges for all murres across the entire circumpolar Arctic. We can also see, for instance, where breeding murres are likely to interact with shipping. We would sorely love better shipping data, and one of the reasons I joined MEOPAR was to find people with better knowledge about Arctic shipping and where risks might occur. If you're knowledgeable about Arctic shipping, I'd love to hear from you. Finally, we can also look at movement year-round, examining energy hotspots. The red areas are regions of high net energy intake, lots of food for little work. Those might be especially critical habitats to protect year-round. Thank you to MEOPAR for the funding and for organizing this conference despite the pandemic.